So students, we are doing questions from the concepts of physics by Hcverma volume 1, chapter 3, rest and motion kinematics. Question for short answer. Question number 7. Two particles A and B start from rest and move for equal time on a straight line. The particle A has an acceleration A for the first half of the total time and 2A for the second half. The particle B has an acceleration 2A for the first half and A for the second half. Which particle has covered larger distance? We have to be careful about the statements which are given in this. That is, they have started from rest. That means for the both particles, UA initial velocity is 0 and for particle B initial velocity is 0 and move for equal time on a straight line. That is, total time period for A is equal to time period for B. This is given from the first line of this question. We are able to gather this. The particle has acceleration as A for the first half of the total time. Therefore, displacement of A, we can consider that displacement of A is taken into two parts. That is displacement of A1. That is, you can write as UAT plus half acceleration during the first half is A. So A into E square. Since initial velocity of A is 0, I strike it off and I have the distance covered is half into A into T. This I can mark this as total time as T. Therefore T by 2 T whole square. After this, I have displacement of A in the second half, but we must know that the particle has got a velocity, initial velocity at the beginning of the second half. So to get this, I'll write as initial velocity of A during the second half into T by 2 plus half into 2A into T by 2 the whole square. How to get this initial velocity during the second half? We have equation V is equal to U plus AT, and with that I can apply like this: UA2 that is equal to 0 plus A into T by 2. This UA2 I can directly apply here and I will get SA2 that is equal to AT by 2 the whole multiplied by T by 2 plus half, and this cancels and I have AT square by 4. If I carefully look at this equation, then I'll get this answer as AT square by 4 plus AT square by 4 that is equal to AT square by 2. And previously I got SA2 as AT square by 8. So total distance covered by AA is SA that is equal to SA1 plus SA2 that is equal to AT square by 8 plus AT square by 2. That comes out to be AT square plus 4AT square, that is 5AT square divided by 8. With this, having known this, this is the distance covered by A during the total time t. We move on to see what is the distance covered by B. B has initial velocity 0, but it is very clearly mentioned that it has got acceleration 2a in the first half. Therefore, SB1 is equal to UBT plus half into acceleration of B into t square. Since this is 0, starting from rest, I have half into 2a into t by 2 the whole square. That is a t square by 4. And what is the distance covered by B in the second half? SB2, that is equal to UB2 into t by 2 plus half into acceleration of B during the second half is only a into t by 2 the whole square. How to get the initial velocity of B during the second half? The same, the idea which is there, which is applied for A, we will apply here. That is V is equal to U plus AT, and I will apply UB2, that is equal to 0 plus A. Here because initial acceleration of A is 2a, therefore I'll put 2a into t by 2. Therefore it becomes AT. Now SB2, this I'll put here, and I will get AT into t by 2 plus half a into t square by 4. So I have now this is equal to a t square by 2 plus a t square by 2 plus a t square by 8. So this becomes equal to 5a t square by 8. Already I have total SB is equal to SB1 plus SB2, displacement in the first half plus displacement in the second half. I have displacement in the first half as AT square by 4. AT square by 4 plus 5A t square by 8. So I have this total equal to 2AT square plus 5AT square, that is 7AT square divided by 8. Now you can very well see the comparing this value, that is A's displacement during the time period t and B's displacement during the time period t, shows that B will cover larger distance, that is SB is more than SA. I hope it was clear to you, students. Thank you very much.